Well, at least I need to make one thing off my bucket list. I'll take a quick recording on this math method exam 2. Multi-choice questions. This is a factor of this polynomial. If it's a factor, x equals to a is a root. So you can solve that in and get everything equated to 0. And you will get a 3a cubed minus 6a squared equals to 0. Take out the 3a squared, and you have a minus 2 equals to 0. Notice a is not equal to 0, so a is just 2. Option D. Question 2. F and g are functions such that f dash equals to g dash minus 2. You have these two conditions. I think it actually modified a Cambridge textbook question. Anyway, I just rearrange this equation to get g dash x equals to f dash x plus 2. And I can anti-derive both sides, getting from g dash to g, and then f dash integrated to f plus 2x at c. And I substitute x equals to 0. Then x equals to 0, you have 2 equals to 1 plus 0 at c. So c equals to 1. Option B. Basically, this is just an antiderivative. Question 3. A to b, f of x dx is 3. We would like to calculate b to a, 2 lots of f of x plus 3 dx. Notice the reversed order. What I'm going to do is I'll first reverse the order of a to b. So I have b to a, f of x dx equals to negative 3. Then I can split the integral, I call it I, equals to 2 lots of b to a, f of x dx plus integral b to a, 3 dx. Just notice if you see the 2 only goes with f of x, you can only take the 2 out from f of x, not from this guy. So I'm going to get 2 times minus 3, and we should have 3x from b to a. Then you have 2 times minus 3 plus 3a minus b. And you can take out, let's say, a 3. So you have a 3, a minus b, take 2. So that's why I'll choose option D, dot. Question 4. This is f of x, a linear function. You might want to say, okay, y equals to, if I say this is a 2, this is a 1, the gradient is minus 2. So we have minus 2 x plus 2. And then if I anti-derive this function, because we want to find the graph of an antiderivative, you probably get minus x squared plus 2x at c, okay? And this is a negative parabola. You need to have a turning point at x equals to 1. Yep, option B. Super easy. Okay, this is a normal distribution question. I'll probably have to pick up my CAS calculator. Mean value is 120, standard deviation is 50. Andrew scored 117.9. Chloe's score is 1.2 standard deviations above the mean. So I need to use 120 at 1.2 times 50. What I'm going to do is I'll grab my CAS. I'll go for menu 552. Lower bound is Andrew's score, 117.9. Upper bound is 1.2 times 15 plus 120. And the mean value is 120. Standard deviation is 50. Press OK. The answer is 0.4406. 0.4406. So it should be option C. Oh, a bias coin has a probability of 0.4 of showing heads. So P equals to 0.4. Flip 10 times, N is 10. So this is a binomial. I would like to get at most twice. That means if I have X is a binomial MP here. Then I want to get a probability of X at most is less than or equal to 0, to greater than or equal to 0. So I'm going to use a binom CDF. Binom CDF 10.4 from 0 to 2. So you get a 0.16728, which is closest to, I can use the button here, round these to 2 decimal places. 0.17, closest to 0.17, okay? Okay. This is a graph G. It's a quintic power 5, okay? Polynomial. This is a domain restriction. We want to find the range directed to 2 decimal places. So what I'm going to do is I'll plot this graph. Let's say Control I, insert the graph, x to the power 5, x3x to the power 4, plus 2x to the power 3, x6x plus 2. Notice I'll put the domain restriction, minus 1.1, less than or equal to x, less than or equal to 0, enter. And I probably can stretch this graph a little bit, say, go from minus 4 to, or maybe I can just go for minus 2 here. And looks like a 0 here, but I need to double check. Maybe I can use a minus 1 here. And yeah, let's have a look. Menu, analyze graph. Is this lowest value? Oh, okay. It's not actually 0. It's slightly lower than 0. And then I just need to look at the upper bound or the largest y value. So if I round the y values to 2 decimal places, notice I'm hovering my hands. If you want to get less or more decimal places, just hover your cursor using this touchpad. Hover your cursor around that value. Press plus, you get more decimal places, minus less decimal places. So it's from minus 0.06 to 4.71. Option B. All right, this one gets more interesting. Okay, this is a graph f of x equals to x to the power 3 minus x. Area A equals to area B. Yep, area of region marked A is the same as the area of region marked B. A is greater than 0. So I'll say the total signed area. I just ignore the point here, but I can see this is x equals to y. Once you have these two equal regions, this is negative, this is positive. They should cancel each other out. So I'm going to solve 0 to a, x to the power 3 minus x dx equals to 0. Something along this line. Okay, so I solve shift plus 0 to a, x to the power 3 minus x dx equals to 0 for a greater than 0. A is root 2. Is there any root 2? Yeah, option C. Given that the graph of y equals to g of x has a local minimum at a 2, 1, the graph of y equals to g minus 2x must have, probably I can try, if it's 2 here, 1 here. Without losing the generality, I would say I can make g of x equals to x minus 2 squared plus 1. And then I just plot this function. Yeah, because that's a local minimum anyway. So I can go for the graphs. Notice this is F2. I can just make x minus 2 squared plus 1. I can see a local minimum here, which is the absolute minimum actually. Then I press tab. What I want to plot is referring to F2, F2 of minus 2x. So you can see this point is still a local minimum at a minus 1, 1. So option A. Okay. let f of x equals to e to the power 2x plus 3, gx is x squared plus 2x minus 3, h of x is g of f. Oh, interestingly, this time they didn't use the GOF or fork notation, but anyway, it's the same thing. So just say f of x is assigned to exponential 2x plus 3. And g of x is assigned to x squared plus 2x minus 3. And h of x is assigned to g of f of x. So I would like to get the derivative in terms of the other function or the other functions. So let's try d dx h of x. If that's equal to that, let me try equation for f of x times f of x plus y. True. Oh, actually the first one is correct. That's interesting. All right. So this is another CAS question. Consider the function f of x is log ex and gx is sine x plus 2, the range of the function. Okay, so basically, if you look at the range of this guy, it is actually 2 minus 1, 2 plus 1, which is 1, 2, 3. And the range of the inner function is domain of the is subset of the domain of the outer function. Yep, 1 to 3 is definitely a subset of 0 to infinity. So the opposite function exists. Next thing is I'm going to do Control I, add graphs. Natural log stands for log e and sine x plus 2. And you can see this is a periodic function. Well, I think this would be pi on 2 here, if I'm not mistaken. So each time I get a pi on 2 and add a 2 pi, I get a maximum. Each time I have a minus pi on 2 or add a 2 pi, subtract 2 pi, I get a minimum. Yep, I just go for 0 here. This is a 0 and a minimum and a maximum. 1.5708, that is the approximation to pi on 2. And I want to find, let's say, it doesn't look like infinity, it doesn't look like it's 1, it doesn't look like it's 3, so it has to be option C. You might also want to use f max. This function is f4. f4 of x comma x, you get, let's say, these values, and you try f4 that value. It's natural log of minus 1 to the power of n minus 2. But usually I would say this will give you, let's say odd numbers, because you can only see that, let's say, here, etc., etc. So it's definitely natural log 3, okay? For example, if you sub in pi on 2, that's natural log 3. If you sub in, let's say, plus 2 pi, that's natural log 3, etc., etc. This is a great question. Maybe it's a good idea to treat it like exam 1 question later. Anyway, this is just my consideration. A game consists of rolling a fair six-sided die. Points are scored according to the following table. So we have 1, 2, 3, 4, 5, 6. This is the number on the die, and x is the number of points. So for 1 or 2, we have plus 6, plus 6. For 3, 4, 5, we have minus 3, minus 3, minus 3. For 6, that's a plus 9. And the probabilities will be directly relevant to the number. So this is a fair six-sided die. Each number will get an equal chance. So eventually, if I want to figure out the mean value, I just need to multiply each x value by the relevant probability. You can see all of them will be multiplied to 1 over 6. Therefore, what I'm going to do is I'll use the sum button, curly bracket, 6, 6, minus 3, and minus 3, plus 9. Each of them just multiply the same number. If they have different probabilities, I will use another curly bracket to enter all the respective probability in that order. But in this case, I don't have to. Then I'm just multiplying each one by the probability and add up every product. That is the sum button, and I get a 2. So option A. All right. Okay, the inverse function of this exponential. Notice this is a restricted domain, which is the range of f inverse, okay? And I just need to swap x and y. So I probably grab my CAS calculator, say, solve x equals to exponential 2y plus 4, comma for y. I get a rule first. This is a natural log x minus 4 divided by 2 and x is greater than 0. But this is assuming that it was coming from the maximal domain of exponential, which is not the case because we only have 0 to half, which means I'm going to put this whole function between 0 and half because that is the inverse. 0 less than that for x. So you get e to the power of 4 and e to the power of 5 as a number set. Just be careful with C and D. This is -4, but it doesn't have a bracket here, so it's not correct. You have to select D. Oh, I think the multi-choice questions are very accessible, very easy. Okay. Log function, square root function, defined over its maximal domain, each defined over its maximal domain. And we want to find the maximal domain of the product function. Well, who needs by hand calculation if one could access the CAS calculator? Well, this is not a good mathematical practice, but in the exams, the time is precious. You don't want to linger too long on each question. Well, this is from a pragmatic point of view. But when you get to university or let's say higher level studies, you probably need more understanding than just getting the marks. So you have -7 on 2, less than or equal to x, less than -3, or 1 to infinity, which means option D is the correct answer. Lovely. Question 15. Function g is differentiable over domain R and satisfies g2 equals to g4 equals to a, and g-2 equals to g-4 equals to b. Okay, px is gx times g2x. We want to find p-2. So what I'm going to do is I'll take the derivative. So you might get g dash of x times g2x plus just g of x times, notice the chain rule here. It's 2 lots of g dash 2x. Okay. So then I'll substitute 2 and get a g dash 2 is a. G dash 2 times 2 is g4. Oh, by the way, sorry. I better write them clearly. Firstly, I get a g dash of 2 times g of 4. So g dash of 2 is b. G4 is a, b times a. Then I have g of 2 times 2 times g dash of 2 times 2 is 4. So this bit is b, this bit is a. So I get 2 lots of AB. So eventually we have 3 lots of AB. Option C. It's not tricky, but you just need to get extra cautious. Question 16, let x be a normal random variable that satisfies probability x greater than 6 equals to probability x less than 8 equals to probability z less than 0.5. The way I treat it, usually I will visualize by looking at a very good symmetrical normal diagram. We don't know the mean value, so I just put it here. But as you can see, x greater than 6 is here, maybe. And this area is equal to probability x less than 8 equal to this area. So they must be symmetrical. And if you assign them in the middle, this is your mean value, 6, 7, 8. It's equidistant, 1 unit each side of the mean. And then this is x, 6. You can align that to this bit 0.5, and maybe this is actually no. I have to make sure if it's a z, you should have a 0 here. This is actually a minus 0.5. This is 0.5. So there is a hidden condition. Probability z is greater than minus 0.5. What I'm going to do is I'll equate x less than 8 to probability of z less than 0.5. Then according to the conversion formula, z equals to x minus mean. X is 8 minus the mean divided by sigma. Therefore, it has to be 1 divided by sigma, and sigma is 2. Okay? So this is a really good conceptual question, and it may have a great chance to be a potential exam 1 question. Remember your math method and specialist math exam 2, they will be assessing outcome 1, 2, 3. So something that could appear on the exam 1, definitely it could appear on exam 2. But at exam 1, mostly they just assess outcome 1, which is like a simple facts, skills, and procedures with some simple applications. In exam 2, you often get more complicated questions. Okay. In a set of 10 products, 6 products are defective. 2 products are randomly selected without replacement from the set of 10 products. It is known that at most one of the 2 selected products is defective. What is the probability that exactly one of the 2 selected products is defective? In this case, I'll call it D is hypergeometric, okay? Like totally we have 6 defective. We choose X. And then you have 4 good ones. You only choose 2, let's say at 2 minus X must be good ones. And totally you have can choose 2, okay? So that's how I would form a probability function. Let's call it capital D equals to X. That is 6 choose X times 4 choose 2 minus X divided by 10 choose, for example, 2. And I would like, a conditional probability that probability given that D is less than or equal to 1. And I want an exactly D equals to 1. So I will get a probability D equals to 1 divided by probability of D equals to 0 plus probability of D equals to 1, something like that. Let's rub that out and write that properly. D equals to 1. Okay. So that's how I would proceed with this question. For example, define PR of X is equal to NCR. And 6 choose X times NCR. 4 choose 2 minus X and NCR. 10 choose 2. There I just need to find the probability of 1 divided by probability of 0 plus probability of 1. So the answer is 4 over 5. Question 17, done. Question 18 is a very nice pseudocode question. Okay. Well, the algorithm is to find an approximate solution to log EX minus X over 3 equal to 0. And you can see this is called a bisection method. You have a for loop from I equals to 1 to 3. This is called a counter, okay? We do the following things for 3 rounds. either this one or this one or this one, depending on the condition, depending on whether the condition is satisfied or not. So basically, I just follow the code here. I'll show you what I do, okay? You probably want to write down something as a desk check, but I don't do that very often because I'm not teaching, let's say, algorithm or data applied computing, data analysis or software development. But I think if you want to work that out steadily, just go for a desk check, okay? What I'll do is I'll first define f of x, it's natural log x minus x over 3. Then I'll use this back assign button, like 4 is assigned to A, and 6 is assigned to B. Next thing is I'll start the first round of the execution. Like I'll begin by A plus B divided by 2 assigned to C. So a fraction, A plus B divided by 2 assigned to C. Yep, it's 5. Now I need to check the first condition, say f of C, control enter. Is that between minus 0.01 or 0.1? No, it's outside. So I can't print C. I have to go to the else if, like then f of A times f of C, is that less than 0? That's true, because the values have different signs. Then I can just, let's say, execute this code here. Otherwise, if it's still greater than 0, I have to go back to choose C assigned to A, okay? So I'll go for C assigned to B. Remember, it's your C value here assigned to the B value. Once you get a C assigned to B, then you come back here. And this is the second round. Second round, you just go for, actually, I can just repeat this step. Repeat that step. It's 4.5 or 9 over 2. And now, then I'll go back to the second round, the first if. I'll try f of C, control enter. This time I do have a value between minus 0.01 and a 0.01. So now I can follow that if condition to print C. So what is my current C here? 4.5. Which of the following numbers will be printed by this algorithm? Option B. Okay. Question 19. B and C be the discrete random variables whose values are obtained from 2 rows of a fair 6-sided die. So I think all of you learned this in year 9 or year 10 in probability. Well, usually I would go for a table. And in each cell, I probably get, let's say, I get a value. I'll get a list of numbers, say 1, 1, and the probability for the likelihood for a 1 and a 1 at the same time will be 1 out of 36. And you can see there are 1, 2, 3, 4, 5, 6, 6 times 6. There will be 36 entries in this table. And I would like the probability that a quadratic equation has at least one real solution. That means at least one real solution to have delta equals to b squared minus 4 times 1 times c is greater than or equal to 0. So I need my b squared greater than or equal to c. So actually, I can just figure out if I have my b squared, actually 4c, 4 times c. I might also get, let's say, an augmented column next to C. I'll put a 4C here. That's 4, 8, 12, 16, 25, 20, not 20, 20, and 24. And I also get an augmented row of numbers, B squared. That is 1, 4, 9, 16, 25, 36. Then for each outcome, if it's 1 and 1, I'll check, okay, if 1 is 1 greater than or equal to 4, if not, I'll just put a cross. No good. 4 equal to 4. That's good. As long as it has an equal sign. 9 is greater than 4, good. 16 greater than 4, 25 greater than 4, 36 greater than 4. Okay, first row is done. Then 1 is less than 8, no good. 4 is less than 8, no good. 9 is greater than 8, good, 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 good. 1 is less than 12, no good. 4 is less than 12, no good. 9 is less than 12, no good. 16 is greater than 12, good, good, good. No good, no good, no good. Good, actually. 16 equal to 16, okay? Now I have a good, 25 greater than 16, 36 greater than 16. And no good, 1 is less than 20, 4 less, 9 is less, 16 is less than that, 25 is greater than that, 36 is greater than that. And 1 is less than that, 4 is less than that, 9 is less than that, 16 is less than that, 25 is greater than that, 36 is greater than that. So eventually, out of the 36 outcomes, each with probability 1 out of 36, how many needs to multiply by? Needs to be multiplied by 1 over 36. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Option A. Problem step. This is a really good this is a good, very good year 11 question, to be honest with you. It combined the quadratic discriminant and the discrete probability together. Question 20, it's this question that got me pausing for quite a while. I'm still contemplating on this question, but I think the answer is option A. A quick geometric method is like if you have a system of two linear equations with a unique solutions, so they only intersect once. And because they only intersect once, the gradients must be different gradients. Another system of two linear equations with infinitely many solutions. So say you have a line like that, you also have a line like that. They are coincidental. Therefore, two equations actually become one equation. So the four linear equation, effectively, you only have three. And it's combined into a new system of four linear equations. So let's say if I have a L1, L2, and I don't have to use L4, I just need an L3. I can combine L3 into L1 by addition or subtraction, and or I can combine L3 into L2 with plus or minus. I can use the phrase called a linear combination, etc., etc. So let's say if L3 is parallel to L1, then we might get a line like that, and you can combine the two lines into one. So it may well be, let's say, intersecting once somewhere, or let's say if L3 is not parallel to L1, etc., you might get, let's say, a different slope, but you still get L2. Let's call this L dash, or you might get L dash here, parallel. So you might get a zero solution or just one solution. The reason why it can't be infinitely many is because the first two lines are not parallel to each other, nor coincidental with each other, I would say. Another possible method is well, this is where I have to use something outside of the math method syllabus, because I'll talk a little bit about linear algebra. Basically, there are totally four equations, with the third and the fourth eventually being one. So actually, you can create, say, You can create like a 4 rows, 3 columns. And you might say this is A1, A2, B1, C1. That represents A1x, B1y equals to C1. And you get A2, B2, and a C2. And you get A3, B3, C3. This is called augmented matrix. And the last one is effectively 3 zeros. And you can use, let's say, what is that called? It's called a reduced row echelon form. So actually, yeah, you get a, let's say, a matrix like that. But eventually, it's either no solution or zero solution. So I just get a, without a reduced row echelon form, I just get a row echelon form. For example, you can see these entries like eventually you would get 0x 0y equals to 1. And this is not true. We can discard that. Then we just get 1y equals to that thing, and x plus b3 over a3 equals to that thing. So this thing here, if it doesn't exist, then you wouldn't be able to solve the first equation. So that means you definitely can get, say, zero solution, no solution, or if that thing is defined, for example, the denominator a2b3, a3b2 here is not equal to 0, then you probably can get, for example, let's say a y value equals to that, and then you can place this back and get the x value. So that's why, well, this is using something beyond the mathematics curriculum. And for those of you who are interested in university math, you will find the exact answer to this question in the XY plane, only 2 dimensions. When you get to university, okay, like these 2 things are called pivots, okay? Anyway, I'm talking too much about anything outside the VC curriculum. So let's move on to section B here, okay? So if you take a look at section B, question 1, we have a function gx equals to x squared minus 1 times x plus 1 squared. And you can see there is x minus 1, x plus 1. If you factorize the first quadratic, we want the x value of the stationary point of inflection, coordinates of the local minimum, average rate of change between 0 and 2, equations of tangent lines. So there are multiple equations. Okay, describe the sequence of 2 transformations. Let A, B be real, positive real numbers. We have this transformed graph. A times gx plus b has a local minimum on the x-axis. A parameter problem. Okay, so I'll probably open up a new problem. Define g of x to x squared minus 1 times x plus 1 squared. If you use the factor form, the point of inflection will occur at x equals to minus 1, but the question wants the x value. So just say gx equals to x minus 1, x plus 1 cubed. Triple factor. X equals to minus 1 for SPOI. Local minimum, F minimum, G of x, x, half. So G of half is minus 27 over 16. This time you need a coordinates. This one is just the x value, so make sure you answer the question. Average rate of change, AVGRC, average rate of change, G of x, comma, x equals to 0 to x equals to 2. So 0 plus 2 is 2. Interval length, that's 40. So we say delta G over delta X equals to G2 minus G0 divided by 2 minus 0. That is 40. And the equation of tangent. So what I'm going to do is I'll just get dg of x is assigned to derivative g of x, comma x, and solve dg of x equals to minus 2 for x. You have two values. There we have y equals to tangent line g of x, comma x equals to curly bracket minus 3 on 2, comma 0. So you get two equations, okay? Okay, describe a sequence of two transformations that maps the graph of G to the graph y equals to G y minus x. So basically, well, you could get a gx to G of minus x first, and a G of minus x to G of minus bracket x minus 1. So I'm taking the priorities of Dr. T, okay? So you have a reflection about the y-axis, and then translation by 1 unit to the right. You don't have to say translation by 1 unit in the positive direction of the x-axis. Just say translation 1 unit to the right. That's enough, I would say. Of course, you might also put an alternative answer here. You can go for gx to G of x plus 1. That is a translation by 1 unit to the left first, and then G of x plus 1 map to G of minus x plus 1. So the second step is a reflection about the y-axis, okay? But it has to be in this order, so it's actually called T-doctor. You just need one possible sequence. You don't have to list both sequences, okay? And now, I know this is a dilation factor, so your old graph may look like that, I would say. So if it's stretched, it's something like that, okay? And if it's adding a b here, it's translating that up. But all in all, there is no vertical, there is only vertical translation, no horizontal translation. So the minimum must always occur at, let's say, a half here. If you look back, look at the part B, it's only the y value changing. So I need to have G of half times A plus B to get me the y coordinate. And that is the local minimum on the x-axis. So we equate that to 0 and get B in terms of A. So we can actually solve A times G of half plus B equals to 0 for B. 27A over 16. Okay. Part G, each real number k, let gk be the function gk is x squared minus k times x plus k squared. Find all values of k for which the graph gkx has exactly one x-intercept. So you might have a situation where case 1, If x squared equals to k has no solution, that means k is less than 0. So then x equals to minus k only. That is exactly one x-intercept. You might get, let's say, another case. Well, always look out for some special case. That may well be, let's say, some critical cases. For example, if you get k equals to 0, then your g naught x will be x squared times x squared, which is x to the power 4. So that is x equals to 0 only. Combine them together. K is less than or equal to 0, or I would say k belongs to minus infinity to 0, because the question says real number of k rather than integer numbers or discrete values. Find all values of k for which the graph has exactly one stationary point. Again, like this one, I definitely know k equals to 0 is one answer, because note k equals to 0 is also a special case, as g0x equals to x to the power 4 has one stationary point, like that. And then let's try to find the location of the stationary point, g dash of x equals to 0. So in this case, I'm gonna define gk of x equal to x squared minus k times x plus k squared. Just take the derivative equal to 0, or you can use the zeros button. You get a 3 expression like that. Actually, you can write two radical expression like plus or minus, okay? Plus or minus square root minus k. And I know this must be defined. So what if they disappear? How can I make these two disappearing? Well, I just need to make the discriminant, anything under the square root, less than 0. So then I'll just solve that a bit. Less than 0 for k, from minus a to 0. So basically, all values of k, you have to have this thing, etc. You can also write it like that. And you could verify this using, let's say, some kind of slider, but I don't think that is a very efficient approach. Well, I can show you what happens. For example, create a slider. Now I'll change the setting. Let's say minus 20, maybe 10, step size 0.1. Okay, let's see what happens, okay? If I push that to, now you can see if k is some positive numbers, even though this turning point is getting closer to the x-axis, we still get, let's say, a twist, a stationary point of inflection, and also, let's say, a minimum. And once it gets to 0, yep, it's x to the power 4. And if it's, let's say, less than 0, you can see the behavior of this quartic function. Well, it's not that clear to see, but I'll change this to maybe 15, and this is minus 15, something like that. Then you can see the behavior is like, this location is gonna be my like a k value, okay, k value, and eventually it becomes let's say a positive root on the x-axis. And then if you push that up, maybe try some larger value, maybe say 500. See, something's gonna happen. Can you see the twist here? The point of inflection appears to be flatter and flatter, eventually up to a point where you get, let's say, -8. If you get an exactly -8 here, this will be a stationary point of inflection. So anything in between, it's like, it's like that, okay? It's like that. So basically, anything less than or equal to -8 or greater than or equal to greater than 0, I would say, it will make the quartic function here to have one stationary point of inflection and a one minimum, okay? All right, that's pretty much this question. Let's move on. 12 marks. Okay, this is a composite function. The priority part will be the log EX, and it gives you a domain restriction maximal domain. D is R plus. Show that F can be expressed in this form. So probably I need to show some index law. I can't move the 4 here, but I can actually write e to the power of bringing the 3 to write e log e of x to the power 3. And this e log e will cancel. So that is 4x to the power 3. It's shown. So it is important to merge these 3 into the argument here as the power and then cancel e and log e. And the domain restriction is x greater than 0. So area bounded by the graph f of x, I just go for 1 to 2, from 1 to 2. X to the power of 3 dx with a 4 there. Shift plus 1 to 2, 4x to the power of 3 dx, 15. 15 square units, okay? The function g is the antiderivative of f that passes through the point 1 minus 5. Okay, it satisfies g1 equals to -5. Sketch the function g on the axis below over the domain D, which is x greater than 0. So it has to be an open circle, okay? Non-negotiable. They have specified you have to use the correct domain. Label the coordinates of the endpoint, the x-intercept, and the endpoint, which means x approaches to 0, y is what? G is what? X-intercept and the points on the graph where x equals to 1 and x equals to 2. So firstly, I'm gonna say my g of x is integrating from 1 to x. I'll write a 4u to the power 3 du here, plus g of 1. So I'll calculate this definite integral plus -5 and get a rule and then sketch this function. 1 to x, 4u to the power 3 du minus 5. And the g of x is just x to the power 4 minus 6. Then if you calculate everything, well, in this case, I may well get a minus 1 here. This is a 1, and this is a 2. If you take a look at, okay, minus 10 to 10. Minus 10 to 10. And I'll go for g of x for x greater than 0. So you can see this is a 0 minus 6. You get a 1 minus 5, and maybe 2, 10. Let's have a look. G2 equals to 10. Yep. And I need to find this value here. It's a slightly zeros, g of x comma x for x greater than 0. 6 to the power 1/4. Control enter. 1.56 something. Okay, excellent. Let's have a look. Oh, I'll put a point here. It's a hollow point, okay? Going through this point, 1 comma minus 5. Going through here, 6 to the power 1/4, 0. And 2 comma 10. Yeah, I've got 4 points. Let's just get a very nice graph through them. Well, I didn't get I didn't get my overhead camera at my home here. So I just do it I just do a nice iPad graph, but you make sure you draw it flatter. It's not a quadratic, it's a quartic, okay? And that's over the suitable domain restriction. Okay, y equals to g of x. Hopefully that's correct. Okay, let a is greater than 0.5. The area bounded by the graph of y equals to f of x, the x-axis, and the line x equals to 0.5, and x equals to a. So it's x equals to 0.5 to x equals to a under the graph f of x can be expressed as ga plus b. Find the value of b. So one thing I would say is we want to integrate 0.5 to from 0.5 to a, integrating f of x dx. And that's equal to ga plus b. So I can do shift plus 0.5 to a, f of x, or haven't defined f of x, just go for 4x to the power 3 dx equals to g of a plus b. We get something along this line, and let's try to solve this equation for b. B is 95 over 16. So actually you get a 16a to the power 4 minus 1 divided by 16 equals to a to the power 4 plus b take 6. So you actually get b equals to 95 over 16. Alternatively, you might realize g of x is an antiderivative. So you say 0.5 to a fx dx equals to g of x between 0.5 to a. And you get g of a take away g 0.5. So this bit will be your b value, okay? So you can just simply evaluate g 0.5 with a negative. So it's 95 over 16. Okay. Now, consider the function h for x greater than 1.5. H of x is f x 2x minus 3 minus f of x. Find a quadratic expression for h dash. Cancel, otherwise find the coordinates of the point on the graph where the gradient is a minimum. On the original graph, the gradient of h is strictly decreasing. Find the largest possible value of p. Okay, so f of x is assigned to 4x to the power 3, and h of x is assigned to f 2x minus 3 minus f of x, something like that. I can just get the derivative h of x comma x. And this is a quadratic expression. I might want to go for -3/5, complete the square. You get that. So you can see when x equals to 12/7, the minimum gradient is minus 216/7. But to find the point on the original graph, I have to slot this value back to h of x. And then, yeah, that's pretty much what it is. And if you look at the decimal number, this is 1.7 something, okay? 1.7 something. So anyway, it doesn't specify it has to be turning point form. So you might want to say 84x to the power 2 minus 288x plus 260 for x greater than 1.5, or 84x minus 12/7 square minus 216/7. And when x equals to 12/7, like h double dash x equals to 0 for your minimum gradient. So the point is 12/7, h of 12/7. And I can do some evaluation, 12/7 here. And say h of 12/7. That is minus 972 divided by 49. And the gradient is strictly decreasing. Well, if you look at the parabola like that, we know this is x approaching to 1.5. This point is x equals to 12/7, which is rounded to 1.714, etc., etc. So actually, the graph is strictly decreasing from here to here, including this p-value. The largest p-value is just a turning point value here. So it's 12/7. And by the way, this point on the original graph y equals h of x should be a point of inflection. It's a point of inflection, okay? Anyway, this is question 2. Oh, yeah, next page is question 3. Let h of t be 2 sine 4 pi t over 25 plus 1/5 sine 3 pi t plus 3 t is greater than or equal to 0. The function h models the water height in meters on the tide height marker at the base of a boat ramp. The variable t represents the time in hours after midnight. T equals to 6 represents 6 a.m. So find the water height, find the average height, and yeah, height more than 1.4 between some time, total amount of time. So this is very, these three parts are very doable in my opinion. Absolute maximum after 6 a.m. The time when it occurs. Answer in meters, 2 decimal places, time correct to the nearest minute. Okay, nearest minute. Total amount of time. Show that, find a period. Okay. Let's just chuck this in the calculator and see what happens, okay? Go up, menu, insert a problem, add a graph. 2 sine of 4 pi times x divided by 25 plus 1/5 sine 3 pi times x plus 3, something like that. Then I look at 0 to 24. Yeah, this is a graph. And maybe I can look at, let's say, -1 here, just make this 0. So just want to look at, for example, maybe 26 whatsoever. Anyway, height at 6 a.m. So F1 of 6, control enter, 2 decimal places. And average height is like the average value. So it's not average rate of change. 1 over, well, 6 a.m. is t equals to 6. This is t equals to 6 p.m. That's 6, that's 80. T equals to 6 to t equals to 80. So I need to use 18 minus 6, and an integral shift plus 6 to 18 f1 of t dt. Control enter. The decimal place is 2.98, something like that. Okay. And a boat requires a water height of more than 1.4 meters to be safely launched off the ramp between 6 a.m. and 6 p.m. So between t equals to 6 and t equals to 18. The total amount of time where it is safe to launch the boat, give your answer in hours, correct, to two decimal places. So if I just look at, for example, a 6 here and an 18 here, something like that, I'm able to plot another 1.4. And if I look at a larger screen, we can see, this is an interesting case where you have, let's say, for example, if I zoom in a little bit, zoom box, just look at this particular section, you can see from here to here, you get two values, okay? And now let me just use Control Escape. So two values. Between these two values, t values, you will have, the height less than 1.4, which is no good. And also, then from the third solution to the last solution, you get another period of time which is not very safe, okay? So what I'm going to do is, I know this is from 18 to 6, or totally 12 hours. I just need to figure out the two time interval and subtract the two time intervals from 12 hours available. So what I'm going to do is I'll solve, or actually I can just go for zeros. F1 of t minus 1.4 comma t, given that 12, 6 less than t less than 18. So I get, let's say, these four solutions, 7.8, 7.9 something. You can see these two values are very close. So just subtract them to find the first time difference. I will assign that as T1, okay? And the other two values, I'll just go for that minus that. We will assign that to T2. Control Enter. And I go for 12, total 12 available hours minus T1 minus T2. And the remaining will be the safe time to launch the boat, okay? So that's what I'm gonna do. We say solve h of t less than 1.4, less than or equal to 1.4 for t belongs to 6 to 12. We get some time period. We have t belongs to 7.8035 to 7.9493 union, let's say 8.27617 until 10.66388 . So the total safe time equals to 12 minus delta T1 minus delta T2, okay? So I'll call this delta T2, and I'll call this delta T1, and that is equal to 9.4665, which is rounded to 9.47. hours. 2 decimal places. Should be fine. Okay. Find the absolute maximum height of the water on this Monday after 6 a.m. and the time when it occurs on this Monday. After 6 a.m. So it's up to 24, t equals 24 within the same day. So you can actually find menu, analyze graph, maximum, click this graph, and search it across. This is 15.503, 5.1962. You can see this is close to 0.5 hours, which is like, if I copy this value, paste it here, times 60. Well, I know it's 15 hours after the midnight. You can see this is closest to 30 minutes, okay? So what I will say is, T equals to 15.503 something, 34 hours. And this is 15.30 or 3:30 p.m. on Monday. And the H max equals to 5.196163, rounded to 2 decimal places in meters. So 5.20 meters. I like this number, no? 5.20. In Chinese, that means I love you, okay? Anyway. Part E, show that H 25K equals to 3 for all positive integer K. Okay, probably take a snippet. This is a function. Take a snippet. You don't have to copy it again, but you need to substitute correctly. This is a show that equation. So you get a 2 sine 4 pi 25K divided by 25 plus 1/5 sine of 75 pi add 3. Notice that K belongs to Z plus. So you can see any integer multiple of pi, when you sub into sine, that is 0. And then you get a 2 sine of 4 pi K plus 3. And that is also 0. So it's a 3. Show it. But just be mindful, you better argue from all possible value of K rather than just taking the specific value. You can't just say K is 1, so it's a 4 pi, sine 4 pi is 0. Or K is, you know, K is 1. You have to retain the K there, in my opinion, okay? In my humble opinion. Okay, so that is, this thing here. Ooh, actually, my good note kept telling me the LaTeX code for certain things. Okay, especially I wrote some tidy mathematical expression. The next thing is find the period of the function h. It is suggesting that for each 25 hours, it repeats a number 3 here. But I don't think this is period. If I take a closer look, for example, it has something to do with 25. For example, if I say f1 of, just take any value, f1 of 1 is that. So how about f1 of 1 plus 25? Okay. and f1 of 1 plus 50. That is that. And f1 of 1 plus 75. Well, let me try. Is f1 of t plus 25 equals to f1 of t? I don't think it shows a true, so is 20, if 25 doesn't work, I try 50. True. So it was somewhat helpful on the 25K thing, but if you write down period is 25 hours, I don't think it's the correct period. So the actual correct period should be 50. The way I approached this one was looking at the combined function here. I was looking at the combined function here. For example, this is a combined circular function. So P1 from the first component is 2 pi over 4 pi over 25. So actually you'll get a 25 over 2, if I'm not mistaken. And this thing here will have a P2 equals to 2 pi over 3 pi, which actually gives you 2 over 3, okay? In order to find the combined period, I'm taking the lowest common multiple between two separate periods. This is how I would approach this one. And I do have my CAS calculator. You put LCM. You put 25 over 2, comma, 2 on 3, enter. The period is 50. We call it the minimum positive period. And the period has a time unit. Yep, that should be the correct answer, I suppose. So that's that question. And we have 2 more questions to go. Question 4, a claim is a request to an insurance company for a payment after an incident. Basically, if you drive a boo-boo and somebody else drives a boo-boo, bang! Whose responsibility is that? We don't know. But in Australia, probably you need to contact your insurance company, and the insurance company will look after you if you are purchased or signed up to a comprehensive insurance. Okay, and hopefully you get a good deal, a good quote. Okay. Anyway, company A offers car insurance. Let X be a random variable representing the claim amount in thousands of dollars. So it's already in thousands of dollars. For each claim to insurance company A, probability density function of X is given by 8 over 9x to the power 4. X is greater than 2/3. So this is like X belongs to 2/3 to infinity. The mean amount EX is 2/3 to infinity. X times 8 over 9x to the power 4 dx. Just get your calculator, control up, manual insert a problem, add a calculator. F of x is assigned to 8 over 9x to the power 4. We just integrate 2 on 3 to infinity. X times f of x dx. Here we go, it's 1. And the other part is a claim of more than 2,000. X greater than 2 is classified as large. So I want to figure out X greater than 2. The probability is 2 to infinity. And we could have 8 over 9x to the power 4 dx. And you have to, let's say, use infinity as the upper bound. 2 on 3, infinity. Bear with me, not 2 on 3. Well, my brain is not working very well, especially working very late. F of x dx, 1 over 27. This should be correct, 1 over 27. So make sure you use f of x here rather than x times f of x, because you don't want to copy the previous calculation for the expected value to calculate the probability. Probability is just the area under the function. And given that a claim classified as large, find a probability that is more than 4 cells. So we should have probability of x greater than 4 given x greater than 2. This is a conditional probability. You just go for 4 to infinity f of x dx divided by 2 to infinity f of x dx, or you can write 1 over 27 here. And the question didn't ask for any decimal values, so you need to go for that divided by that. So it's 1/8. You could also say 0.125, etc., etc. But I just get the answer. 1 on 8. And you can see this is like 2 marks. So show some working. In a random sample of 10 claims, find the probability that more than one claim is classified as large. So it could be either large or not. So large has a probability 1 out of 27. This is 26 out of 27. We call that a binomial distribution. Large claims out of 10, and the probability is 1 out of 27. So we have probability L is more than 1. So I think that is from 2 to 10, okay? Or you could have worked out 1 minus probability L equals to 1 minus probability L equals to 0, something along these lines, okay? And you could actually use binom CDF 10, 1 out of 27 from 2 to 10. Yep, this is a probability. Or you can just say 1 minus binom PDF 10, 1 out of 27, 1 minus binom PDF 10, 1 out of 27, 0. So still get the same answer, okay? So it's 0.051. All right. A household has 2 cars insured with company A. For each car, there is a 20% chance that a claim will be made next year, independent of the other car. Okay? So car 1, you could have, let's say, claim, no claim. Once you made the claim, if it's identified as large or not large, so 0.2 or 1/5, 20%. This is 1 over 27 and a 26 out of 27. Now, if you make no claim at all, there is no need to identify large or small. So it's just 5 over 4, okay? Find the probability that next year in this household, there is at least 1 claim classified as large. At the most, 1 claim can be made per car next year. So we don't double claim on one particular car. It only happens once, but we have 2 cars. So it may well be, claiming twice. At least 1 claim classified as large. So let C be the number of claims. We have 2 cars, and the probability of having a claim and it's identified as large. So you need to get, let's say, 1/5 times 1 out of 27. So that is actually 1 out of 135, I suppose. Then I would like at least 1 claim classified as large. So we say probability of C greater than or equal to 1. That is a binomial CDF anyway. Binomial CDF. 2, 1 out of 135, comma, 1 to 2. Okay, so binomial CDF. 2, comma, 1 out of 135, comma, 1 to 2. The probability is 0.0147599 something. And it's rounded to 4 decimal places, 0.0148. That's done. And let's move on. Hopefully it's correct. Let TA be a random variable that approximates the time taken in days for company A to settle a claim. Suppose TA follows a normal distribution of mean 32 at a standard deviation of 7. So TA is a normal 32, 7 squared. Find the probability less than 45. Well, I can just grab my CAS calculator. For example, norm CDF minus infinity, 45, mean value is 32, standard deviation is 7. This is a probability. And a company A settles 99.5% of the claims within, that is less than or equal to K days. Find the value of K. Give your answer correct to the nearest whole number. So I'm taking inverse norm. 0.995, comma, 32, comma, 7. And it's rounded to 50. And a confidence interval question. 80 claims, 76 were paid. So the proportion of claims paid by company B. So I go for menu 665. X is 76, N is 80, C level is 95%. So okay, press enter. Yep, I'll get the answer. 3 easy marks. So this answer is 0.96835, which is rounded to, I'll probably write probability TA less than 45 here. And we want to have probability of TA less than or equal to K equals to 0.995. And K equals to 50.0308. So 50 days. Okay, the other thing is I want to find approximate 95% confidence interval. So 0.90224, 0.99775, or 6, rounded to 0.902, 0.998. I'm just using normal rounding method. But technically speaking, you might want to use a square bracket, but I don't think it's necessary, okay? Just not use the normal convention to round, okay? Okay, last part. All right, TB is a random variable normal distribution, mean of 25 days, standard deviation of 5 days. And TA was already plotted on the diagram here. And you can see for this normal distribution, the maximum occurs here, okay? Like it's 32, the mean value, okay? 32. So then sketch the probability function for TB equals to, TB is normal 25 squared. So I need to have, let's say, my turning point along this line maybe. So write something here. Mu B equals to 25. And for your reference, I probably will press Control I, add a graphs. Now, you might want to type something out. It's called norm PDF, if I'm not mistaken. I'll put an X here, 32,7, enter. And you can see this is not an awfully large, awfully tall bell-shaped curve. So I probably just need, let's say 0.1 and maybe minus 0.02, something along this line. And maybe I can use a 55 something. Then you can see it's stretched very well, okay? And I put a 5 here. And I can identify this is analyzed graph maximum. There we go. So it's 0.056, 0.057 something. And the next thing is if I have another norm PDF, I say norm PDF, variable is X, mean value is 25, and standard deviation is 5. So how does that look? Ladies and gentlemen, there we go. We just need to imitate this graph, but make sure this graph is taller and narrower. It's more squished, more concentrated or convergent to the middle. If you want more accuracy, I would say I try to get an analyzed graph intersection. So roughly speaking, you will get, let's say, the turning point, the intersection point here, okay? And you can sort of get some kind of symmetry, okay? Symmetry. Very close to, let's say, that number, 29.44 something. Maybe it's roughly here, something like that. Then you can use the similar kind of, symmetry to get an idea of what's happening, okay? And if you want to get a more accurate turning point location, I would say maximum, select the red one, 0.079 something, roughly 0.8. So maybe slightly higher. Okay. The question didn't ask for any labeling of coordinates, but getting these coordinates would definitely help you to get a more accurate shape. Okay. And you don't have to sketch, for example, the horizontal asymptote. It is well known to all of us is y equals to 0, but the question didn't ask for it. I think if you get something like that, it should be good. Okay. And this is TB following normal distribution, 25,5 squared. And I think in your textbook, either Cambridge Essential or Jacaranda or Nelson or Ederolo, they must have mentioned the general formula for normal distribution, like f of x equals to 1 over sigma value square root of 2 pi e to the power minus half x minus mu divided by sigma in the bracket square. So you might want to slot in, let's say, a 5 here, a 5 here, and a 25 here. And for the black curve, it's 7 here, 7 here, and a 32 here, and plot them. Make sure you realize it's roughly 0.10 here, okay? So that gives you a good scale to look at the graphs. All right, I'm going to finish that up. David is planning to build a vegetable garden, okay, in his backyard, using an existing wall for one side and up to 12 meters of timber for the remaining sides. So I only need to build 3 sides. Okay, this is a classic year 11 quadratic or algebra problem. So the total length L, not total length, L equals to total available minus 2 widths. So therefore the area, let's call this A1 of W, equals to W times L. That is W times 12 minus 2W. And it gives you 12W minus 2W squared. Next thing is we want to find the maximum possible area. Well, this is too easy. We just need to realize 12 minus W must be greater than 0. So W must less than 6, between 0 and 6. And yeah, this is pretty much a quadratic problem, but you can say take the derivative equals to 12 minus 4W equals to 0. So W equals to 3, and A1 maximum equals to 12 times 3 minus 2 times 9. So you actually get a 36 minus 18. That is 18 meters squared. Okay? You don't have to use a calculator. You just do it by hand. Even for some a lot of year 10 students, if they don't use this method, they may use, let's say, a graph. This is area 1. So it's a parabola. This is 0. This is 6 in the middle. You have a 3. And then substitute to find the maximum. Okay. Okay, David realizes that his new vegetable garden must fit within the boundary created by his garden path. Let the existing wall be defined by the x-axis and the boundary of the garden path be defined by the continuous function g below. So the first part from 1 to k, that is the 3 log ex. The second part is another log function, 2 log e, 12 minus x from k to 11. Both x and y have units of meters. David considers a rectangular vegetable garden with 2 corners on existing wall. So one corner is here, another corner is here. We might label them as P and Q. This is P, this is Q. And 8W square meters be the area of the rectangular vegetable garden. W is the width. But remember, in the diagram here, this is the y value. This is also the y value, W. Given that G is continuous, find the value of K. So two sides need to have the same Y value. For example, I sub in K here, and equate them. So I just need to write, I think, 3 log E of K equals to 2 log E of 12 minus K. And we can solve that by CAS. Let's just go for right. I'll insert another problem. I'll call it G1 of x equals to assigned to 3 natural log x. G2 of x is assigned to 2 natural log 12 minus x. Solve G1 of k equals to G2 of k, comma k. K equals to 4. It's a lovely value, okay? A lovely value. Okay. Show that AW equals to W times 12 minus e to the power half W minus e to the power third W. Okay, so let me take a snippet here. What I'm gonna do is, this is a show data question. One thing is, when I get the P, say G1 of X equals to W, that is equal to 3 log E of X. So W on 3 equals to log EX. And X equals to e to the power W divided by 3. And G2 of X equals to W as well. I'm talking about the point Q here. Equals to 2 lots of log E 12 minus X. So W over 2 equals to log E of 12 minus X. 12 minus X equals to e to the power W on 2, and X is 12 minus e to the power W on 2. And the difference between these two X values will be the length here. So L equals to 12 minus e to the power W on 2 minus e to the power W on 3. Therefore, the AW is W times L. That is W times 12 minus e to the power half W minus e to the power W over 3. So to show that is finished. Hence, find the value of W that gives the maximum area of this rectangular vegetable garden and state the maximum of AW. Give your answer corrected to decimal places. So I'm trying to figure out. But anyway, this W should be larger than 0 but smaller than GK, okay? Ooh. So I can have GY of 4, that is 6 natural log 2. And I'm going to, not solve. Just say A2W is assigned to W times 12 minus exponential W on 2 minus exponential W on 3. And F maximum A2W, W, 0 to 6 natural log 2. Control Enter. You get a 2.49 something. And A2 of that is 15.52. Okay, so that is something like that. Okay. Can David build the rectangular vegetable garden of maximum area as described in part B3 with less than 12 meters of timber? Justify the answer. So when W equals to 2.49, maybe I carry more decimal places, 0.08 meters. Your L equals to, your L is this thing. It's 6.2316, etc. meters. So totally equals to L plus 2W. And that is that plus 2 lots of that. 11.21, 33 something, which is less than 12 meters timber available. Therefore, yes, David will be happily getting this done. Okay? All right. Yeah. Finally, David considers a pentagonal vegetable garden. Pentagonal means you have 5 sides using the existing wall for one side, okay? 1 side, 2 sides, 3 sides, 4 sides, 5 sides. He requires 2 sides of equal length W, here and here. 4 are from the existing wall to the garden path, GX. Both of these sides are perpendicular to the existing wall. The remaining 2 sides will meet at point KGK. Right. This is 4, 6 natural log of 2. Find the maximum possible area. Yep. For this pentagonal vegetable garden that David can build with 12 meters of timber or less. I think this is an interesting thing to consider. David can build with 12 meters of timber or less. So the total length must be less than 12. Not only should we find the area expression or area function, but also we need to find, let's say, for example, a suitable condition to add up the 4 sides and are less than or equal to 12. Well, you may get other ways, like you can use, let's say, one trapezium, add another trapezium. But in fact, don't waste something you already did. For example, like that. This is a triangle. This speed is your AW in which part? In part B2. And this is a triangle. We know this L is 12 minus e to the power half W minus e to the power third W. And this thing here, it's W. And this y value here is 6 natural log 2. So this is 6 natural log 2 minus W. All right, all you need to do is let A3W equals to AW plus half base times height. Everything will be in terms of, let's say, W. And then the four sides, each side. So that is, this is G1 of, actually I can write it explicitly. This was e to the power W on 3, comma W. And this is my Q, this is my P. 12 minus e to the power W on 2, comma W. And everything else will be shortest distance, okay? Distance, W, W. There we go. We need, let's say, square root of something. We have 4 minus e to the power W on 3, bracket square, plus 6 natural log 2 minus W, bracket square. Maybe I should write that smaller. This is just one side. We also need another side plus 2W less than or equal to 12. Okay, so we have 12 minus e to the power half W minus 4. That is 8 minus e to the power half W squared plus W minus 6 natural log of 2, bracket squared. I should guess this a square root sign marginally longer, okay? And then once we get the W values, we can use F max. Let's have a look. This is one square root, add another square root. 8 minus exponential W over 2, whole thing squared, plus W minus 6 natural log of 2, whole thing squared, plus 2W less than or equal to 12. So you get that inequality. You can see this is a quite long inequality, okay? And then you just solve that for W. Press Control Enter. But the CAS calculator won't solve that analytically. So if that's the case, instead of forcing it, try to, let's say, solve an equation. Or what I would do, I will grab just the left-hand side here and put given that W equals to X and copy that and insert a graph. Paste the graph here, press enter. And I want this thing to be less than 12. So I definitely need to get, let's say, like 15 or 16 something for the Y, okay? So you can see this is the graph, quite an interesting one. And I probably need to get, let's say, this thing less than 12, less than or equal to 12. And your X or W should be greater than 0. Therefore, you look at these two intersection points. So for example, I put a 0 here. and get a manual analyze graph intersection between that and that, and that and that. So basically, you will find these two values, and just be mindful within these two values, you probably need more decimal places for better accuracy. In this case, I'm going to say this implies 2.638315 less than or equal to W less than or equal to 4.600572 dot dot dot, and then use F max for A3W. Okay, A3W. I haven't defined A3W. I should do that now. I do have A2W. Good. So A3W is assigned to A2W, which I defined before, plus half. I think I had that expression. Yep, just this expression. That is the length times 6 natural log 2 minus W. And F max, A3W, W, 2.638315, 4.600572. Control Enter. And you will see it occurs at the left endpoint, which suggests this graph should be, let's say, strictly decreasing. So if I just verify that, just look at, let's say, 2 something and 5 something. Maybe I use like a 30. So you can see this graph is always decreasing. That's why you get the maximum on the left restriction. And then you just go for A3 of that. Problem solved. Yep. For maximum W equals to 2.638315, etc., etc. This is at the left end point. And therefore, the maximum equals to A3 2.638315. You can see I kept the 6 or 7 decimal places, which will guarantee, a reasonable accuracy. So it's rounded to, this is in meters, and this is 19.88 meters squared. Okay. Right. Hopefully I get everything correct. All right. And yep. Now, one thing off my bucket list. So I'll try to find other times to do other relevant videos whatsoever. Maybe I should try general math. I haven't been doing general math videos for quite a while. Last time was 5 years ago. So maybe I'll find a time to do a general math video, I suppose. Okay, all the best for your exam preparation. I'll see you all in the near future. Bye-bye.